Hello, this is Mrs. Boots, and this is our lesson on polynomial operations. We're actually covering three different operations. We're going to do evaluation, addition, and subtraction. So what does evaluate mean? You hear about that word, and maybe you've had it in English, but how do we use it in math? Evaluate means I want to find an answer. Okay, so I'm going to do something to combine all my terms and get a single number. Typically, evaluate can be substituted with the words plug it in and simplify, okay? So whatever I'm given, whatever values I'm given, I'm going to plug it into the equation and use that to simplify, okay? So everywhere I see a letter that has a value, I'm just going to put parentheses and leave a space. That way I can go back and plug my numbers in, just like we did with the quadratic formula. Okay, so in example 1, I'm given this expression. It's got A's and B's in it. And they tell me that A is -5 and B is -3. Okay, so I'm going to write out my expression. And because I've already got parentheses in there, I'm going to turn those parentheses into square brackets. That way I don't confuse my parentheses for the numbers that I actually plug in, okay? So let's write it down. I've got a bracket. I see an A and a B. I've got a 2. Oh, there's another A, and it's squared minus a B. Easy enough, right? Now, here's the part where most students make a mistake. Make sure we plug the right numbers in the right spots, right? What did this first parenthesis represent? A. What's A? -5. Okay, -5. Cool. All right. This was a B. B is 3. This one's an A. That's -5. This one's a B. B was 3. Okay, so now we can simplify. This is where your PEMDAS comes in handy. Your what? Yeah, PEMDAS. Okay. Yeah, some of you have the acronym memorized. Please excuse my dear Aunt Sally, or whatever other little riddles that you've got that do that. Okay, basically we do what? Parentheses, exponents, we multiply, divide, add, and subtract. Okay, now it's kind of grouped. Okay, add and subtract you can do simultaneously. Multiply and divide we can do simultaneously. Exponents and parentheses. Okay, so let's look at how would that work? All right, these brackets are parentheses. I have to simplify what's inside. Now, yes, let's get real. You could plug this whole thing in the calculator exactly as you see it. Exactly means every single parenthesis where it's supposed to be as it's written. If you do that, you always get the right answer. Okay? But most students don't do that. They leave the parentheses out. Okay, so what is -5 minus 3? That's -8. Okay, and I have plus 2. This is a -5 squared. What is -5 squared? 25. Okay, and then I have a -3 at the end. Now, I see some multiplication that needs to be taken care of before I can do my add subtract. I have 2 sets of multiplications. Okay, 3 times -8 is -24. 2 times 25 is 50, and then I have a -3. Okay, I'm weird, I know, surprise, in that I like to combine all my negatives first and then combine my positives. That just makes it easier for me. But you can do whatever makes it easier for you. So I would have 50 minus 27, and that gives me 22. So I evaluated this expression for A equals -B, so A equals -5, and B equals 3, and I get 22. So anytime I evaluate a function, I'm plugging something in, and now I'm going to get the answer for what I plugged in. That sounds easy enough, right? It is. It really is that easy. So let's look at example 2. Example 2 is the exact same thing written in a different format, which usually messes students up. I now have a function, f of x. It's 3x cubed minus x plus 5. Okay, the highest exponent is a 3, so I know it's a cubic equation. That's awesome. But now what do I do with it? Okay, so see this beautiful 1 right here? That one's inside the parentheses. What letter's inside the parentheses? X, okay? So I'm plugging the 1 in for the x. I'm going to do exactly like I did in example 1. I'm going to write my function with parentheses. So I have 3 parentheses cubed minus parentheses plus 5. Okay? It doesn't matter what I'm plugging into my function. This is where I start. Now I'm going to actually plug it in. We want to plug in a 1. I know, it's kind of anticlimactic because it's 1, right? Okay, so 1 cubed is 1. Right, okay. You got it. So 1 times 3 is 3, minus 1 plus 5. Okay, 3 minus 1 is 2. 2 plus 5 is 7. All right, so the way we write this, so that everyone understands, is we would say that the f of 1 equals to 7. So that everyone would know clearly my function has a value of 7 when I plug a 1 in. Okay? Now let's figure out what we would get if we plug in a negative 1. We start the exact same spot. All right? Exact same spot. Not a big deal. We write out the equation. 3 parentheses cubed minus parentheses plus 5. Yes, you could plug this into your calculator exactly as you see it, right? The point is exactly, right? We have to have the parentheses. What are we plugging in? Negative 1. Okay, do you think we're going to get the same thing? A lot of students do, but we don't. I'll even be nice. I'm going to show you how you can plug this into the calculator. Since I know that's what you're doing, you're not actually sitting here working in your head, at least not most students. Okay, so I would plug it into the calculator just like this. Notice that what you see on the board, what you see on the calculator, match. Make sure you're using negative signs when you're supposed to and subtraction signs when you're supposed to, okay? So negative 1 cubed, funny enough, is negative 1. So 3 times negative 1, negative and negative make it positive, plus 5. Okay, so now I have negative 3 plus 6, that's equal to 3. If we didn't get 3 when we plugged it into the calculator, which, by the way, I did, okay? So I would write that the f of negative 1 equals to 3. That tells me I plugged in a negative 1. Okay, let's do the last one. Plug in a 0. So I have 3 parentheses cubed minus parentheses plus 5. I know, you probably went through and just went ahead and wrote your zeros. That's cool. You can do that. All right, 0. 3 times 0, 0. Minus 0, plus 5. What is it? Yeah, it's 5. Okay, so plugging in 0 obviously is the easiest thing to evaluate because most of your terms are going to be 0. And it's real super easy to add and subtract zeros. That's not a problem. Example 3. We have a fraction. That upsets most people, but that's okay. We're just going to plug the numbers in. That's all we're asked to do is simply plug the numbers in and evaluate. So I write down my equation. 4 divided by, where there's an x, parentheses, minus 1. I just have to remember that all of that is in the denominator. And it's no big deal. What are we plugging in? We're plugging in the value that's inside the parentheses on the other side. That's a positive 1. That's easy enough. Okay, so on the top, I still have a 4. What do I have on the bottom? 1 minus 1 is 0. So the answer is 0, right? No, it's not 0. Okay, can I divide by 0? No, we cannot divide by 0. Okay, so what we would put is we would actually put no solution. No solution. Okay? Anytime you have divided by 0, you have no solution. Not possible. Okay? Can't do it. I can't divide by nothing. Alright, same thing, only we're plugging in a different value. So, write down the equation. 4 divided by, parentheses, minus 1. You're saying, Miss Boots, we're going to have a problem. We're plugging in a 1 again. No! What are we plugging in? Negative 1. Okay, negative 1. It's going to turn out different. I promise. It's going to turn out different. It's very different when you lose $1 versus getting paid $1, right? Same thing here. Very different. Okay, 4 is on top. Negative 1 plus negative 1 is negative 2. Ha ha. Okay, 4 divided by negative 2 is negative 2. Okay, so the G of negative 1, and you're saying, why is it G instead of F this time? We name functions by different letters. Each letter stands for something, okay? So G could be gravity, it could be gamma radiation, it could be the grocery bill, I don't know. But there's some function with a G. That's okay. It may be the shortcut for a chemical compound. That's its text message name. I don't know. All right? Example 4, we're using P. What could P be? P could be pressure. All right? We're talking about air pressure, not the stress that you may be under, okay? But pressure, okay? I have another function, completely different one. I'm plugging in 3 different values. We do the same thing. Evaluate. Every single time you see parentheses with that number inside, it means evaluate. So I put the 3, put my square root up, there's my x. Put my 2. Now, if I really want to be a go-getter, super ambitious, I know what my first step is. Same function all 3 times. I go ahead and write it all 3 times. That's no big deal. It's a shortcut. That's okay. All right, what are we plugging in the first time? 0. What am I plugging in the second time? 2. What am I plugging in the third time? 18. Okay. That was easy. Now we got to actually do the math. All right. So I have 3 square root of what? What is 0 minus 2? It's negative 2. Now, can we take the square root of negative 2? Technically, you're going to get an imaginary, right? I'm going to get 3i square root 2. Do we really want imaginary numbers? No, we really don't. Okay? So if you're dealing with theoretical math, in theory, it's 3i square root of 2. If you're in physics, it's no solution. Why? Because you can't go to the store and get a board that is 3i square root of 2 long. It doesn't happen. Not in real life. So we don't do imaginaries. All right? So you can box this answer because you are in theoretical math. Just remember, if you were building a building, this would be a no solution. Okay? Easy enough. Let's look at the second one. When we plug in 2, what do we get? Well, still got my 3 out front. 2 minus 2 is 0. It's not a no solution. What's the square root of 0? Yeah, it's 0. So I have 3 times 0. It's 0. Okay. Is that possible? Yes. You can have no money. It's not fun, but it is possible. Ask your parents, right? It's possible. You can have no money. But we don't like it, right? Third one. What did we plug in? 18. Okay. So let's simplify. 3 still on the outside. What have we got? 18 minus 2. That is 16. Oh, What's the square root of 16? 4. Very good. Okay, so this is 3 times 4, which is 12. Okay, so if I plug in 18, I get a 12. That is how we evaluate. Now we have a couple of examples with addition and subtraction. Okay, so I kind of have this crazy question for you. What does it mean to add and subtract? You're sitting here looking at me like, Mrs. Boots, I mean, come on, fingers and toes, you just count, right? Yeah, but we have all these X's and Y's and A's and B's and all these other letters. So what does it really mean to add and subtract? Okay, so when we have the variables in there, add and subtract really comes down to one fancy phrase. That phrase is combine like terms. Combine like terms. Okay? So if it's an x squared, it can only be added with x squareds. X's with x's, constants with constants, y's with y's, whatever it is, they have to be alike. Agreed? Okay. So, in my first example, the first thing I want to look at before I start just randomly combining things that are like terms is what is the operation? What am I asked to do here? I'm asked to add, okay? Always check your operation. If I'm asked to add, I would distribute a positive 1 to everything inside. Is that going to change the value of anything in that second set of parentheses? No. I can multiply by positive 1 all day long. It's not going to change anything, okay? So I still have my x squared plus 1, and now we can just drop all the parentheses. 3x squared minus 4x minus 6. Okay, now like terms. I have an x squared. I always go in order. I go from highest exponent to lowest exponent. That way my answer is in standard form and I don't have to think about anything. Did I miss something, right? Do I have another x squared? Yes. Okay. What's the coefficient in front of this one? It's a 1. I know. You did this in Algebra 1, right? Okay. 1 plus 3 is 4. So I have 4x squared. That's cool. All right. Now I see an x. Do I have an x anywhere else? No. So we're just going to drop the x down. All right? Now my constants. Well, I've only got 2 of those, right? Positive 1, negative 6. So negative 6 plus 1 is negative 5. Now I want you to look real close. Did we take care of every single term in the previous row? Yes. Notice I don't cross them out. I know students who scratch them out. That's a problem if you ever make a mistake because then you got to go through and erase and figure out what it was you scratched out. So I don't scratch them out. I just underline them or circle them, put squiggles underneath them, and then I know. This is simplified for the original expression. That's it. You combine like terms. We can't add these together. We can't go 4 minus 5 because our x squareds, x's, and constants don't match. Let's look at number 2. What kind of operation are we performing? We are subtracting. So I have to distribute that negative 1 to everything inside the parentheses. Is it going to change anything? Yes. Negative 1's always change the sign, okay? So I still have my stuff in the first set of parentheses. X squared plus 4 minus 3x. I know they're not in order and it really bugs me, but we're just going to write them down because we're just going to combine like terms anyway. Now second grouping. Minus 3x minus x squared plus 4. All the signs changed. Okay, now we're ready. Start with the highest exponent. X squared. X squared. Okay, so I have x squared minus x squared. Wait, what? 1 minus 1, right? 0. Okay, so kicks and giggles. I'm just going to put 0x squared down here. It's not going to go in my final answer. Okay? Now we have what? I have a minus 3x and a minus 3x. Minus 3 and minus 3 is not 0, right? It's minus 6. So minus 6x. And then we have a positive 4 and a positive 4. 4 plus 4 is 8. Okay? So my final answer would be negative 6x plus 8. That is the simplified algebraic expression for example 2. So add and subtract really isn't that tricky. Add and subtract, all I have to do is pay attention to signs. Is it a negative that needs to be distributed and changes all the signs? Or is it a positive that's not changing any of the signs? The rest of it, you're right, it's just fingers and toes. We add the coefficients in front of the x's and x squareds, and we add our constants. We do not add them all together. This concludes our notes for polynomial operations.